Let's talk about translating quadratic functions. So whenever we talk about translating graphs, we can refer to the main original function as the parent function. This is the one that has nothing special going on, but it's your basic function. So here we're talking about quadratic functions. So our parent function is simply y equals x squared. It's got nothing extra. The graph of y equals x squared starts right at the origin. It's not skinny, it's not wide, nothing special. So we think of that as our parent function for a quadratic function. From there, we can tell that a graph translates. So it can either have a vertical translation or a horizontal translation. When it has a vertical shift or a vertical translation, we think of it as the parent function was simply f of x, and now it's f of x plus k is the generic term. But what it really means is when we add or subtract, it's going to shift our graph. And so, for instance, y equals x squared plus 2. So when we add a number directly to x squared, it makes the graph shift upwards. So this would be a translation of up 2 units. So this graph is the same shape, but it's now sitting up 2 units above where it was before. If we have y equals x squared minus 2, it shifts our graph down 2 units. So it has the same shape, but it shifts it down 2 units. So see, this graph looks the same, but it's just sitting lower by 2 units. Now for the horizontal shift, we call the parent function f of x. The horizontal shift is inside of a grouping symbol, and we usually have a parentheses. So f of x plus k is our generic way to say that. But in a better example, we could look at y equals x plus 5 squared. Now in the grouping symbol, it does the opposite of what you might think. So if it's positive 5, it actually goes to the left 5 units. We normally think of positives go with right. But in this case, in the grouping symbol, it's going to be opposite of what you think. So positive 5 goes left 5. So the same graph is going to be shifted to the left 5 units if it's written that way. If you have x minus 5 squared, again, opposite of what you think, it's going to go to the right 5 units. So that same parent function is just shifting to the right. So it can go up if you add, down if you subtract, and then within a parentheses, it can go to the left if it's positive, and to the right if it was negative. So let's try some more examples. So how did the graph translate? Let's try these. F of x equals x squared minus 7. So if all you have is a minus 7 back there, that would be a vertical shift. It would go down 7 units. The next one is f of x equals x squared plus 1. So again, you're just adding and subtracting directly to the x squared. That's going to go up 1 unit. The next one's in that grouping symbol, so remember, do the opposite of what it looks like. So if it's x minus 3, we're going to go left 3 units because inside that grouping symbol is a horizontal shift. So you're going to go left or right and do the opposite of what you might think. So x plus 11, oh, I didn't do the opposite right there, see that? X minus 3, we need to go back, would be to the right, because minus makes me think of left, but in the grouping symbol, it's the opposite. So x minus 3, I needed to say it was right 3 units. X plus 11 would be to the left, because positive we normally think would go with the right, but it's going to go with the left, 11 units. Now we have x squared plus 4. So the plus 4 back here would mean we go up 4 units, and then I threw in this extra example number 6. Here we have x plus 2 squared minus 3. So this would be a combination. This is something you might see down the road. This would be to the left 2 and down 3. So it has 2 translations. It translated left 2 units and down 3 units. So sometimes you could see a combo. Now let's look at some graphs. So what if they told us to compare the graph to its parent function? So let me rewrite that. Fix Mussy. So what if we were asked to compare the graph to its parent function? So here, I know it's a quadratic parent function because of its shape. It's a U shape. The only graphs we have are parabolas, and they're quadratic when they have this shape of a graph. And so I know my parent function is y equals x squared. So this one went up 3 from the origin, so I would say it's y equals x squared plus 3, and I went up 3 units from my parent function. So those are some good things you could say about that graph. Let's look at another one. So again, my parent function is y equals x squared. So here I've shifted down 8 units from the origin. So I translated down 8 units. So my new function would be y equals x squared minus 8. Let's look at another one. So over here, this graph shifted to the left 3 units. So the parent function is y equals x squared. I translated left 3 units. So my new function would be x plus 3 squared. Remember, you put it back into that grouping symbol, and if it's left, it's positive. Right, it's negative. So over here, I shifted to the right 1 unit. So again, my parent function is the same for all of these. So y equals x squared, and I have translated right 1 unit. So that's going to be y equals x minus 1 squared. So either going from your function to think about the graph, or going from the graph to think back to your parent function. You can answer the questions using the same information.